Hello, welcome to the electrical engineering class. Today I'll explain about the overcurrent relay. Overcurrent protective relay is the simplest and cheapest types of protection device, which is most commonly used for any power system. Based on operating time characteristics, there are three main types of operation: instantaneous, inverse time, and mixed. Instantaneous is just as the name implies. Relay operate with no delay. So if the forward current is passing through here is greater than the pickup value of the relay, this coil is energized and this contact, normally open contact, turn to close, and close path is completed, and trip signal is transmitted to the circuit breaker. And circuit breaker will trip. And this is time current characteristics of that statement. Vertical line represent time and horizontal line represent current. And this curve is represent the instantaneous types relays operation. So if here's pickup value is let's say 800 ampere, and operating time is 0.1 second. So in this state, if the forward current is 700 ampere or 600 ampere, whatever less than 800 ampere, relay will never operate because there are no crossing point is here. So it will never operate. But if the forward current is 900 ampere or 1000 ampere, it's greater than 800 ampere, relay operate immediately in 0.1 second. So how are the inverse time characteristics? These types of relay consist on the induction disk like that. And if the forward current is flowing here, this coil energized and creates some magnetic field. And this magnetic field, the disk makes disk rotate with speed proportional to the current. That means the higher forward current, the disk rotate faster, and vice versa. And this is a fixed contact, and here is a moving contact which will rotate with the disk itself. So when the disk starts to rotate, each contact are getting closer, and when they stick, the closed path is completed, and trip signal is transmitted to the circuit breaker. And circuit breaker will trip. And this diagram represents that statement. So the higher forward current relay operate faster, and lower forward current relay operate slowly. So for example, if the forward current is 1000 ampere, relay operate let's say 1 second. But if the forward current is let's say 400 ampere, relay operate, let's say 3 seconds, like that. And even if the port current is 200 ampere, relay will never operate because there are no cross pointers here. Additionally, there are combined type of the relay, like inverse time and instantaneous in series, like so. So let's see the time current characteristics. So this mixed types relay has the inverse time characteristics, like so, and instantaneous characteristics, something like that. So what happened? Here is overlapped. So as conclusion, this red line represents the operating time characteristics of this mixed types relay. Okay, combined. So that means if this cross point is, let's say, 800 ampere again, if the fault current is less than 800 ampere, they operate as inverse time characteristics. But if the fault current is greater than 800 ampere, relay operate as instantaneously. So this is a diagram of the combination of circuit breaker, current transformer, and overcurrent relay. And this relay is a mixed type, so inverse and instantaneous. Both have a trip signal contact respectively, and either contact operate, trip signal is transmitted to circuit breaker. And CT current transformer have the transform ratio. In this case, the primary side and secondary side is 100 versus 5. And primary side is the power circuit for the load, and secondary side is control circuit for the overcurrent relay. So if the fault current is 1000 ampere, secondary side is 50 ampere. 50 ampere will flow to the overcurrent relay. And this 50 ampere will be a trigger of the relay's operation, with depending on the inverse and instantaneous characteristics, setting value, pickup value. So either or both characteristics operate, the trip signal is transmitted, and circuit breaker receives the trip signal, and it will trip. This is a basic operating principle of the overcurrent relay.